you would want to use the Q class whenever you have some sort of queue in your application, right? So if you had to model a market in, for example, Thailand, you would want to use a queue because we are civilized people and we actually can wait in lines. Whereas if you try to model a market in Chinese, in China, you probably don't want to use queue just to be realistic. Actually, for those of you who got the joke, you had to go to China, no? To experience the chaos in China. I got a chance to go to Shanghai, and you're right that people there don't have the concept of queuing. They don't wait for you. They push through. Right? All right, Antti. All right, lastly, we have map. And let's not confuse ourselves with the Google Maps that you are used to. So who here uses Google Maps? So you guys are Android users. The Google Maps, is it still on the iOS 6? Oh, still? Oh, never mind. I'm sorry. Okay. So when you see the word map here, I don't want you to think about maps that you are normally used to, okay? I want you to actually think of a phone book. So I know in this day and age, we don't use phone books anymore, right? The yellow pages. Or think about dictionary, okay? When you want to look up something, here's an example. Ned, haven't seen you in a long time. How are you? Hey, where's Star? I miss her. Where? What happened to Star? It doesn't feel the same now that she's not in the class. She dropped already? So you have to take her title as the official Kosok in class. So have you used a dictionary before, Ned? Are you okay? All right, I'm not going to pick on Ned today. Charlie, so how do you use a dictionary? Let's say I wanted to look up the word drop. Yeah, right? You would just open the book and then you would try to search for the D section. And then you keep going, right? Because it'll be the next letter that is sorted alphabetically and so on. This dictionary, so when you see the word map, I want you to think of dictionary because that is exactly what the map collection class does. It allows you to look up, that's the keyword, to look up for values based on the key that you know. So for example, if you had a map, this is how you would use the map. This is what we call a key. And by the way, I just want to introduce you this real quickly, but we'll have concrete example later. So this, just pay attention to get the understanding of what a map is and don't have to So, for example, if we wanted to implement the dictionary in our program, probably the most suitable collection class that you want to use is the map class. Because with the map, let's say that you define it as map dictionary. No, I was just reading. Why are you guys so sensitive to? It'd be nice if you were as sensitive to. I said dict, man, dict, D-I-C-T. Anyway. Dictionary. Um, I don't remember the method, but if you had a dictionary type, I say it quickly now, a dictionary of type map, then you could say something like, get, let's say the word drop, and then this will return the definition of the word drop. So maybe you put the definition of drop AppRow, for example. Okay. So just real quickly, I just want to demonstrate how you might use the map class. You have the class of type map. Okay. You might have some method. In this case, I just pick get. I don't know if it's get or not, but it doesn't matter. And you pass in the key. This is what we call the key. The key is what you want to search your map for. So in this case, we're trying to get the definition of the word drop. You pass the word drop, and then you get the definition, the associated definition. Okay. All right. So we're done. And lastly, the sorted map is simply just everything in that map is sorted by the key. Okay. So a fine example of that would be the dictionary, for example, right? Because everything in the dictionary is sorted alphabetically, right? And here is simply just the explanation of what the map and the sorted map is. All right, group of key value pairs. This is key, this is value pairs. Map, and then the sorted map is simply map with ascending key ordering. So these people who came in late, are they like really confident that they got an A on the midterm, so they don't have to pay attention anymore to the lecture? That's okay. Okay, so generics. Who has heard of the term generic before? And I noticed the term. Yes. So some of you, no, it's not genetic, it's generics. So some of you maybe have used this feature of the Java language before. Some of you had actually, if some of you had used C++ before, I just want to point out that generics is the ripped-off version of C++ template feature, except that I think it's maybe, I don't know, maybe a bit more user-friendly. I think I certainly feel like generics is a bit more user-friendly compared to C++ template. But let's take a look at what a generic is. The collection interface, okay, is generic. By generic, we have to first define what we mean by generic. Okay. So before I define what a generic is, let's look at the world without generic. Okay. What if? Okay, so give me an example besides array of a collection class that we just talked about today. I mean, you just saw it in the previous slide. List. Okay, let's use list. I think, what is wrong with the eraser? It doesn't really erase well. If we did not have generics. So here's an example. I want to have, so we're talking about list, okay, list. I want to have a list of integers, and I want to have a list of, let's say, I don't know, characters. So a list of characters is simply just a string collection, right? By the way, string is also, I think, considered a collection, right? I mean, it falls under the category of collection because string is a collection of what? Characters. And that you actually have interface where you can access each of the string element, right? By string element, we just mean each character. So to a certain extent, the string class is also an example of a collection class, okay? Although we don't define it as such, but I want you guys to think of it that way. Because one can certainly implement the string class by, for example, creating like an array of string, right? You know, and no, not array of string, array of char, right? Anywho, so coming back to the generic, okay? So how do you define, this is one way of, well, how should I explain this? So you know that we are going to use the list class to create a list of integer and then the same list class for char, right? But without generic, you might run into problems like this. You know, list int list, yeah, int list, and then char list. And each of these represents a concrete class you have to implement, okay? Do you see that you actually have to have different class, one for each type, okay? But with the generic feature, okay, you can actually have reuse, and that's the keyword, right? Reuse, that's the theme of our class. Reuse, so you can have something like this, list, int, and list char. And the stuff in the bracket or the diamond symbol simply is how you use the generic keyword. Okay, so you see how this, for this case, we have to implement two different classes, whereas here we reuse the same class, and in this case, list, but we are telling it what type we want the class to be. I mean, to what type of each element we want the class to hold, the collection to hold. So this is what we mean by generic. By generic, we mean that the container can contain a type that you specify at compile time. Does that make a bit more sense? As opposed to having to create a different class, one for each type that you want to put into the collection. So you might not get what I explained earlier, but that's okay because we're going to give you a concrete example. All right. So let me just finish off this slide and say that generic, as I had mentioned earlier, is a built-in language feature. Okay, it's something that Java supports. It helps reducing runtime bugs. Okay, possibly occurred when some classes are to be used with any types of objects. If you don't understand that, that's fine because we have examples that will demonstrate why you would want to use generic. And actually helps improve performance as well. So I actually have one more person that I can pick on, no, for not wearing the right uniform. So I have 3 targets today. Hold on, let me do a check real quick. Yeah, 3 people. So dress properly, yeah? We talked about it during office hour for those of you who came. We want to just adhere to the rules set by July. All right. But I'll go easy on you, nah, Jae. I like to pick on Vicky and Jae more. So here, we are declaring, actually, pink. So can you explain to me what do you think the box class does? Mm-hmm. Yes? That's pretty much it, right? So that's why it's called a box, right? It is simply a box of object. When you have a box of something, right, you can put something in there and then you can take something out. Hence, what we have the put in method and then we have the take out method. Good so far? All right. So down below, can you explain to me the code snippet in the bottom box, what it does.
It put objects in and retrieve the object.
Okay. Be a bit more specific. So what kind of object is putting in? Integer, right? Number is 88. And then take it out. And then what else does it do?
And it print the 88 the number 88.
Thank you. So then it prints out that integer, right? So if you ran this application on your computer, what is the output you should expect to see on the 88? Now, I hope you guys, why did we choose the class object? What is the significance of that? Why is the object class important in Java? How come we didn't choose, let's say, integer class or something else? I don't know, string class. Why did we pick object? Right? Who said every class is an object? Thank you both. And valid to NAM ด้วย Oh. Right? Precisely because all classes in Java extend, right? Extend or is an object. And because of that, because the methods taken in the object class, you can essentially pass in anything to the parameter, and then it will take it, because everything is a subset of the object class. Is that clear? This is why we did not choose string class or array class, right? Because we want to be able to put in any classes into this box. So that's what I wanted to ensure that you guys understand. Now, do you guys remember? I'm not sure if I had alluded to this fact earlier, but the reason why you'd want to use generics, for example, is because it provides you with compile time check, ensuring that the types are consistent. What do I mean by that? Let's take a look at this example. Prin, can you please help me and explain the code snippet on the top left? What we're trying to do there? So we have a box. I'll work with you. We have a box, and then what are we doing to that box? All right, we're trying to put a rectangle into the box. Thank you. Next, Nay. Now we've put a rectangle into the box, and then what are we doing next? We're taking what out? Or what are we expecting to take out? Based on the example, read the example. What are we taking out? What do we think? So forget about the code now. Thank you, Nay. If you had a box and you put a picture of your girlfriend into the box, and then you take it out and then it's somebody else's boyfriend picture, would you be surprised? No? Wow. You were supposed to say yes. Thank you. So we'll keep going now. So the same. So I'd be surprised. Hell, I'd be mad. No, I was kidding. So this is why. So in that, following that understanding, then, if I were the compiler, okay, and you asked me to put in an integer or a rectangle into the box, and then when you take it out, you are trying to take out an integer, I'd be surprised because it doesn't match, right? And this is why when you actually try to run this application, okay, you get a runtime error. Even though when you compile this program, it works perfectly okay. Why? Take it outside. Huh? What? What? Exactly, Tato, thank you very much. That's why she did so well on the midterm. No, just kidding. Yeah. Because both objects, right? Do you see what I mean? Because if you go back, okay, to the class definition of box, what is the input parameter going into put in, and what is the output coming out from take out? Object, right? And since you guys know that all classes derive or extend from object, this is why we can cast an object to be of type rectangle or integer, right? This is why at the compile time, there is no problem. While on the other hand, when you actually run the program, it will not work, because when you cast it to be an integer, that's not the correct type. Java will actually do a runtime check for you whether or not you're casting to the correct type or not. Is that clear? Now, before I move on, let me make sure that all of you understand the difference between compile time and runtime. Nit, what is the difference between compile time and runtime? I picked the right person. You have to speak up a bit. Okay, yeah, that's what the slide says. But okay, and keep going. And what about runtime? Oh, thank you very much, Ploy. Oh, I mean, your name is Nit, is it? Thank you. Actually, to put it simply, okay, the difference between compile time and runtime, for those of you who do not know the difference, and I'm talking to you, Nit, is that compile time is simply just, when you finish writing your code, right? And you save the application, save the file. Normally, what Eclipse, your programming editor, I hope, what it normally does is that once you save the file, it would automatically try to compile the program. You guys know what compiling is, right? You put some gibberish into your text editor, and then it will not compile, right? So that's what we mean by compile time. So in this case, if you coded this program exactly like this, when you save your file, there won't be any problems. Eclipse will be happy. When the program finishes compiling, what's the next step that you normally do? Run it, right? And when you run the application, when your applet shows up or when your console, you get something on the console, that is what we mean by runtime. Is that clear, Nit? Yeah? So now, do you know the difference between compile time and runtime? Explain it. The file? Uh-huh. Yes, that's better. Thank you, Kap. So everyone understands why this slide we show that there's no compile time error and then that there is runtime error now? Everyone sees that? So I'll move on now. Okay. Right. So if I understood you correctly, compile time is used to check syntax error only. You're right. Doesn't check the semantic, but check the syntax. That's the job of compiling. Compiler makes sure that whatever you wrote is a valid Java program. By valid, we mean syntactically correct. So what do I mean by syntactically correct? See, after the midterm, I realize now that I really have to define everything and anything and be sure that, I need to spell out everything, because otherwise, okay, you guys might seem like, you guys are nodding, you guys understand, but actually I realized after I finished grading the midterm that most of you do not understand what I'm trying to say. So I'm going to go a bit slow, and that's okay, because at the end of the day, it's all about understanding of the content, right? So by syntactically correct, the job of the compiler, okay, is to ensure that you're not writing gibberish. And by that I mean, if you have int j is equal to 0, is that a valid Java program? Yes. Now, in another programming language, one can actually declare an integer just like that. Now, my question is that a valid Java program? But in other languages, for example, Python, Ruby, or a lot of dynamically typed languages, this is perfectly valid. But because we are using a Java compiler to check the syntax, we know that this will yield a successful compilation, whereas this will yield a failed compilation. So I hope with that example, so this, in the Java context, we mean that this is syntactically correct. It follows the expected Java syntax, whereas this does not. So I hope you guys have the correct understanding now, and that if on the final exam I ask you, what do I mean by syntactically correct, I would hope that you guys would be able to explain your understanding. No? Okay. Yes. All right. So now let's talk about generics now. The previous example, of putting in an object and taking out an object was to serve as a motivating example of why one would need generic. Now, before we go on, I want to tell you one very important point about programming in general. And this is my personal opinion or my take on it, okay? And let's see what you guys think of it. Every single programming feature, okay, be it generics, class, interface, abstract class, or what have you, every single one of those features serve to solve some problem. Do you understand what I mean? What problem are we currently having in the previous example? We are having a runtime error problem, right? So to understand generic, I want you guys to, look at it from this angle. We are trying to solve the runtime error. And the question you should be asking is, what language facility or feature will allow me to help preventing the runtime error from occurring? The language designer thought that, before we move on, I want to tell you guys or talk about why is that runtime error is a costly problem, a really severe problem. And to explain that, I think I would just give an example of sending spacecraft to the moon. See, if you were the developer at NASA, all right, creating the software for the spacecraft that will be sent to the moon, where do you think the compilation error occurs? Let me ask that again. If you were writing the software for NASA, and the software will be used with the aircraft or spacecraft that is sent to the moon, you were writing the application right now. The question is, when you compile the program, where will you be sitting? Will you be sitting at the moon, or will you be sitting here, some lab? On Earth, right? If the purpose is to send the spacecraft to the moon, if you were developing the software, you would be sitting right here on Earth, no? You wouldn't be sitting on the moon. You agree? Now, my question is, if you guys agree that the compile error is going to happen here on Earth, where do you think the runtime error will occur? Well, if it occurred on the moon, that's fine, because we already accomplished our mission. Where do you think it will occur? On the way, on Earth, right? Or maybe right before you land on the moon. So what's the point? What is the point I'm trying to convey here? I'm trying to show you that the difference between compilation error and the runtime error in terms of the effect that it has on your program usage. Is that clear? What do you think? So my next question is, what is more costly? The compilation error or the runtime error in terms of programming usage? Runtime, right? You know how much it costs to send a spacecraft to the moon, for example? Yes, you can say a lot. I'm not looking for an exact figure. This is why people pay great attention in doing everything that they can to catch all errors before it gets to the runtime error. Because most of the time, if not all the time, the runtime error occurs whenever your users are using your program and not when you are using your program. Is that clear? On the other hand, I'd say 100% of the time, any errors that occur during compilation will be caught by you, or will be, how should I say it, experienced by you, right? Your users are not the ones that will be compiling your program. Hey, this is not Valentine's Day. Well, good that you came in, because now I have one more target to pick on. Sit. Or you can sit closer to me, because I'm going to be picking on you a lot. You can sit right next to Good. Maybe your grade will improve a lot. Learn through osmosis. So is that clear now? I hope you guys understand. So if on the final exam, I asked you to explain me why we should try to prevent runtime error, I would hope that you would be able to understand or explain why it is that we're trying to prevent runtime error. All right, so now that you guys are convinced that runtime errors are bad, so the next thing that I'm going to talk about is how to prevent runtime error using the generic language feature. The generic language feature. So normally, the best case when you the best case, you want the computer to work for you. By that I mean we want the compiler to work out for you, to go through your program and then detect any problems and then flag that, oh, this is a compilation error as opposed to runtime error. So we can use the generic language feature to solve the previous runtime error that we encountered. How? Without formally introducing you to the generic language feature, can someone tell me what the box class actually does now? Tong, can you help me out and give your best attempt to explain what the box class actually is trying to do compared to the previous class?
It has a method.
Yep. Mm-hmm.
Put the parameter O into the item key.
Uh-huh.
It is an object, is it?
Yeah, it is an object. Well, yeah, uh-huh.
And then take out, which is return the item.
Okay. So functionally, it does the same thing, right? It does the same thing. So my question is, thank you, Tong, by the way. But my question is, what is the difference between this example and the previous example? Now, let me remind you that the previous example made use of the object class. Whereas here, we're using a rather strange type called T. What is this type T? Pi. What is this type T? What type is that? Is that a type in Java? Does the Java library provide us with the type T? No. So, well, I mean, at least you answered one of my questions. Java language does not provide concrete type T. So what the heck is this type T? Can someone help me? It's generics. It's generics. So the English language, the word generic means that, I guess, yeah, it's general. It can be, is applicable to, you know, all things. That's why it's generic. Okay. So without further ado, generics is a language facility that allows you to specify the type that you want for that class. So in this case, we are declaring, I want you to take a look at the top left code snippet. And we are saying that the box class can take only a single type. She finally came. The box class can take only a single type. Any types. It's not type T, okay? Any types, as long as it's consistent. So in this example, we are declaring the box that will only take in what type? Gift. What type are we expecting for the box class in this example on the top, I mean the bottom left code snippet? Hey, your name's not Gift. What is it? Integer, right? So everyone understands now how to use generic. Generic is a way to to design a class such that you can use different types for that class. But the constraint is that all types for that class must be of the same type. So for example, in this class, you can only put integers into your box. Is that clear? Anyone has any questions? Because you know, it's better to have questions now than to have questions while you are implementing generics on your final exam. Niran, what's your question? Again, please. Should I explain it in your... Okay. All right. So Niran, in the previous example, when we had runtime errors, you saw that we can put any types as long as it extended from the object class, right? But here, because of generics and because we are declaring the integer class, we can only put in the type, what type? Integer, right? And the way to restrict ourselves to only of a certain type is to use generics. And the syntax for generics is the diamond symbol up there, diamond, T, diamond, right? When you put that right next to your class name, you are essentially telling the compiler that, all right, this class will only work with this type T, whatever type it is when you actually use it, make use of it. Is that clear? So this is why, if you look at the example carefully, there are 3 changes that we had to make to our example. First, the item that we are storing, right? The type previously used to be of object type. Now we're changing it to type T. And next, for put-in method, we changed the parameter from object type to be, again, T, because we are expecting the object that we are putting in to be of that type that we're looking for. And lastly, when we take out the object, we're also specifying that we're expecting it to be of type T. This is a way to restrict our class so that it can be used for only a single type, type T, whatever that type is, whether be it integer, string, some user-defined class, I don't know, some applet class. Is that clear? So to understand the difference between this, to really understand generics, just look back at the previous example where it tried to be generic, right? It tried to be generic by allowing you to put in any objects and taking out any objects. But here, with the language feature, you can restrict yourself to only of a single type. So what do you think will happen when we actually run the program? Compile error. Why? Why would it be compilation error? See, now that we've spent 15 minutes talking about generics and sending spacecraft to the moon, my next question is, if instead of new, right there on the 3rd line, when we call the put in method, okay, and instead of using generics, if we put in the string class, would that be allowed by the compiler? No, right? Because we are specifying from the box class definition that we only expect what type? Integer. And this is why we have a comment that if what we're putting here, okay, if this is not an integer object, the compiler would not allow that to happen. In that way, the programmer knows all errors at compile time. Is that clear? So do you see that now we have pushed the error from runtime to compile time? Anyone has any questions about generics? I mean, it's a very simple concept. Hey, I know where you live. I'll ride my Scoopy to your house. That's a very good question. Can you do that? Can you have one box that is of type integer and another box of type string? Did you say string? Well, let me try to see if I understand you correctly. So you are trying to declare integer type box, and then, so this is box 1. And then maybe, are you saying that another box? Well, I mean, let's go with this example first. So is this syntactically correct? Will the compiler whine? Will the compiler whine or give out errors? No, right? I mean, that's the whole point of generics, is that you can reuse it with different class. You can put in whatever you want. In fact, I mean, to just be a bit you can even put another box inside the box. You see what I mean? I mean, I'm not trying to confuse you guys, but the point is this. Reuse, 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 right? You can reuse the class, the box class, with any types that you want. So in this example, we are instantiating 2 boxes. One is of type integer, and the other is of type string. Is that clear, Mil? Are you all fully recovered now? Is generics too generic for you? But you understand, more or less, or not? Or you were daydreaming about something else? It's okay. I'll see you at office hour. It's okay if you don't get it, okay? The first time that I encountered, okay, my first programming language was not Java. It was, back in my days, C++ was still popular. And the first time that I encountered template, which is the C++ equivalent of Java's generics, I had a lot of trouble trying to understand why you would want to use template or generics. And it's okay, all right? These examples are trivial, okay? But I think the mastery comes when you actually can make use of generics in the appropriate context, okay? Hey, what's going on? I lost the class already? Why are you guys so loud? I'm hoping you guys are talking about generics. If that's the case, I'll be very happy. All right, we have naming convention. Why do you want to know naming convention for generics? It's because when you go through the Java docs of the collection classes, you come across these conventions. So all of them, when you see them in your Java docs API, single uppercase characters. The most commonly used type parameters names are E for element, K for key, N for number, T for type, and V for value. What's the takeaway from this? Just know that refer to this slide whenever you try to go through Java docs. You don't have to memorize it now, okay? Okay, kidding aside, the reason why we want to point this out is so that you understand when you read the Java docs, when you see the uppercase character N, what the library author is trying to convey to you. They're trying to tell you that this class was built so that you use a number generically. Anywho, just make use of the Java docs, and I think you'll appreciate that class more. Oh, I'm a bit tired. All right, so here's a very important language feature, which I don't know if I don't know that C++ does not support this, but it's something that I actually enjoy in Java. So you remember from the previous example, right? And I think this is going to be the last slide until I let you guys go on break. Generic type wildcards. What do we mean by that? So if you declared Okay, let me give you a specific example so that you guys see. If I declared class box that looks like this, what do you think that means? Let's break it down, right? Let's break it down. What is the keyword extends? What does that mean? It's extending from something, right? So let's take it one step at a time. If I had question mark extends t in the normal Java syntax, what does that mean? Assuming that you can have the question mark symbol as your class name. Do you remember? So what does that mean? How to read that? How do you read that? Right? We're saying that the question mark class extends or is a subclass of type T, whatever T is. So for example, if we had my string extends T, or well, extends string. Okay, this is basic Java now. We're saying that my string is a class that extends or inherits or a subclass of the class string, right? Every one of you should know this by now. What if I were to tell you that, okay, this is a hypothetical situation, but what if I were to tell you that the Java language actually allows you to specify, not needing to specify a concrete class. You can use generic. In other words, now in this case, you're having my string is extends or inherits or is a type T. It can be anything, right? T is generic. So with that, now that you're equipped with that knowledge, we're going back to here. Class box question mark extends T. You already know from the previous example that extends T simply means that something is inheriting from type T, right? T can be anything. And the question mark, which is the last piece now, simply is saying that it can be any class. Any class. That's why we called it a wildcard. So, a concrete example, class box extends type T. If we have something like that, when I actually instantiate I don't know, so like string like that extends I don't know, integer. That wouldn't make sense, would it? No, right? You can't have something like that as your example. So we're trying to tell you that here you can have any types that is a subclass of T. It's putting a restriction on the class, okay? And conversely, you can have super. So you can actually specify that whatever class that you are using for the generics has to be a super class or a base class of the type T. And lastly, you can just have an unknown type with a question mark. So we'll go through examples after the break, okay? But I just want you to know that you can actually have this in your Java program. So with that, 10:30 exactly, want you guys to take a break. Oh. Sai now. อ๋อเดี๋ยวซื้อน้ำด้วย At a really high level, at the interface level, right? We define collection, list, set, queue. Now we're trying to include the concrete classes that come with each of the interface. For example, you can see that now, instead of the simplistic class diagram that we saw earlier, now we're actually including, most importantly, the concrete classes defined down here. So when we are talking about list class, right, you have different types of lists, like array list, linked list, right? When you're talking about set, you have a tree set and then a hash set. And then lastly, when you're talking about queue, then you have something like a priority queue. Okay? These are the concrete classes that you'll be making use of when you actually use the collection framework. Now, let's talk about the collection interface. Okay? By interface, I had already told you earlier that when you think or hear the word interface, you should think of what side? No. Good guess. Interface, you should, yes. Oh, wow, so surprising side. Good, right? When we're talking about interface, we should talk about methods. Don't forget to buy Lotto today. I think you are feeling lucky. Right? When we're talking about interface, we should be talking about methods. And what are some of the methods that are common among all collection classes? When you have a collection, what are some of the questions you want to ask from the collection? Right? That's why we have the method size that will return you the size of the collection. You can also ask the collection whether or not it's empty or whether or not it contains some objects that you're looking for. You can add elements, right? Remove elements. And you can iterate, and we'll cover what we mean by iterator, or to iterate the collection. So you can see that these are some of the expected basic operations. And actually, so I think you guys have all taken the data structure class. Is that right? Did you guys have to suffer through data structure implementation? Or you guys just learn about the theory behind data structure? Because when I took data structure, the professor asked us to implement list, to implement array, well, not array, list, map. In my days, we had to do it in C++. Okay. Did you guys have to do the implementation, like write code? Yeah. This is why this should not be new to you at all. See, we're actually very nice. We're not asking you to re-implement these data structures. What we are actually expecting from you is that you should be able to use these classes and use them well. By using them well, we mean you should know which class to use for what context. Okay? All right, so I'm going to have to speed up a bit. When you talk about bulk operations, right, then you can ask further questions. You can ask whether the current collection contains all the elements that the other collection contains, right? You can add all the elements from other collections, remove all, retain all, clear. You can clear the collection, right? These are what we consider or categorize as bulk operations. And then next, then you have array operations, right? These methods are there to convert your collection to the native array. the regular array that you are normally used to. Okay. Most of the time, you end up using these methods, the basic operations, and sometimes the bulk operations. So now, let's talk about the traversing collection example. Have you guys used this construct before? The for each construct? No? Well, if you had a collection, oh, you just showed up. No, I didn't see you. Where were you? Oh, so you show up to school, not my class. Popong, right? That's your name? So what do we have here? What do we have here? Can someone help me? We have an array list. So that's simply just a list, okay? But specialized to be array. So we have an array list, okay? An array list of string. So in other words, visually what we are saying is that we have something like this. So this is a list, and we have, 1, 2, and so on to 4. This is the picture that you should have in your mind when you think of the array list. Something that is contiguous. By the contiguous, we mean each element is adjacent to one another, okay? So for this example, we simply just have a 4-element array list. So if you call the size method on this array list after this line, then you would get the number 4 returned. Now my question is, and this is for you, Popong, can I add, we are adding 1, 2, 3, 4 here. Can I add a number 1 to this array list?
No.
I hope some professor taught you when you were in the bathroom stall the concept of generics. Why not? I mean, I'm adding numbers here. Well, well, not. Oh, good, right? Where we have a list of string. So who taught you this? Oh, you just knew, enlightened. So you can't add an integer to a list of string, right? And because that's the restriction of the generics that we have that we place on this array list container. And I think the point that we want for you to take away from this slide is the for each construct. How do you use the for each construct? This might be new to a lot of you, but it really helps you in traversing your container. So this is what it looks like, and how to use it is that you pass a collection here. You put a collection here, okay, and then you declare the type here, the type of each element. So what's the type of the array list here? String. Okay, and then what do you think that this will output to the screen? 1, 2, 3, 4, right? The strings 1, 2, 3, 4. So I hope that you guys will make good use of this. Okay. Now, when you have a collection like this, we do not recommend that you do something like this, which you guys are probably normally used to. In I equal to 0, and then for this example, it will be like list of strings dot size, and then I++. We don't recommend you doing this because you already have a for each construct, right? So you should use it thus and not try to reinvent the wheel by using something so rudimentary. The only time that you want to use something like this is when you actually need to have the index I, right, as part of your array traversal, collection traversal. Is that clear? Do you see what I mean? The difference in the semantics between this construct, the for each construct, and that for loop construct is that here you simply just want to look at each element in the collection, whereas here you are traversing through each of the collection as well, but maybe you wanted to have the integer I as part of your collection traversal. Anywho, I think the key takeaway is just now you know the for each construct, okay? And if we ask you what is an example of the for each construct on the final exam, I hope that you would know how to answer that. Right, Popol? Because you won't find the answer in the bathroom stall. No? When did you come into the class? I don't remember. Is that? And by the way, that was a really long time. You sat in the bathroom stall for an hour and a half? Really? What did you eat last night? Okay. All right. Still a lot to cover. Okay, so the next thing that we want to get across is that there are two ways that you can traverse the collection. The two ways that are supported by the Java collection framework. One is to use the for each construct, which you have already seen. The second way is to use what we call an iterator. An iterator simply is just that, something that iterates, right? The English language is quite easy in that sense. Whenever you put an or you add an to some word, you basically make a person out of it, or like make a doer out of it, right? So in this case, when we're talking about an iterator, we're talking about something that iterates, yeah? And this is why we say that an iterator is an object. Again, it's still just a regular Java class. It's an object that lets you traverse a collection, and additionally, you can also remove elements from the collection using the iterator. So when you think of the iterator, I want you to have this picture in your mind, because that alone shows you the capability of what the iterator is capable of. So how do you get an iterator? Well, all the collections provide you with a method that we saw in the previous slide called, iterator. Okay? So let's take a look at a concrete example of how you would iterate a collection using the iterator. So first thing first, the only difference between this slide and the previous slide is that whereas in the previous slide we traversed the collection using the for each construct, here we are making use of the iterator construct. Well, not construct, but iterator method. So remind me again, what is the list of strings variable? What is the type? What is it? Huh? List of strings variable is a string? What is it? It's an array list, right? It's an array list of what type? Containing what type? String. So once you have this, to obtain the iterator, you can call the method iterator method to obtain the iterator class of type string. Now my question to you is it always going to be of type string? No, right? What is it dependent on? The array list type. right? Because in this example, I'm going a bit slow, but the array list contains string, and hence the iterator must contain string, and must be of type string. It wouldn't make sense, right, if you had an array list of type string to have an iterator that would iterate through like a sequence of integers, right? So it makes sense that the type here and the type here must match, okay? And how do you iterate then? Now that you have the iterator of type string, it, then to iterate you simply can use the while loop. Because if you look at the previous example, you'll see that the only methods that we are allowed to have has next, which returns the element e, and then remove, right? And I'm going to cover what we mean exactly by remove. But do you guys remember in the previous slide, one of the previous slides, we covered the naming convention for generics, right? And you remember that the capital E refers to element, right? So when you see the capital E, I want you to think of the word element, okay? It's not just by pure coincidence that this is the letter E. There's actually some meaning behind it, right? If it was N, what do you think it tries to convey? Sai, let me test your luck again. Oh, obviously you wouldn't be able to answer because you weren't here when I took cover. Oh, damn it. All right, yes. Okay, so how do you traverse the array? Okay, well, you would use the has next. Why is it the has next? What's the return value from the has next method? Boolean, right? You're asking whether or not the array, the collection still has more elements to be traversed. This is why we use the while loop, right? And then system.out.println it.next, okay, simply returns you the next element in that collection. And then it will just keep going forever, right? Until the has next returns false. So the next implicitly moves you to the next item, yeah, on the list. So there are two ways. The has next does not move, right? Basically the has next is just a Boolean that checks whether or not the next element is available or not. Okay. So the question of which to use, I can't think of a reason. Normally, I'm just going to answer this question based on my experience, but the question is, well, which do you use and in what context? Normally, I just use the for each construct most of the time. But I think as we have seen in the earlier slide, since the iterator has a remove method, perhaps the iterator can be used to iterate over your collection and then removing some of the elements that match your criteria for removal, right? So in that sense, when in that context, you would want to use the iterator as opposed to the for each. So let me summarize again. I think the for each is useful whenever you want to just traverse the collection. Whereas for the iterator, I think you want to use it whenever you want to be able to remove some element from the collection, okay? And that's the difference in terms of usage. Is that clear? Okay, next. Set. So we're moving on to the next collection type, and this is of type set. So on the final exam, you can most likely expect that will ask you the differences between each of the collection type. For example, a list is simply a list, right? A list in a conventional sense that can contain duplicates. You can have duplicates in your list. I mean, Vicky, since she does not know how to use a to-do list before, she would have a bunch of duplicates of the same task that she's supposed to do in her list. So that's the key distinction of a list. You can have duplicates. On the other hand, when you're talking about a set, right, we've already talked about how a set cannot contain duplicates. Okay? And that is the difference between a set and a list. This is why, if you read the slide now, it says that the set interface contains only methods inherited from collection and adds restriction that duplicate elements are prohibited. Clear? So think of set, think of not Vicky, because Vicky likes duplicate in her list. We don't have duplicates in our to-do list, so we'll use something like set. Yeah? So Vicky, since I picked on you so much, when you take the final exam, you better not mess up on this question. Nah? And now I hope you remember the difference between set and list. Further, two set instances are equal if they contain the same elements. Right? If you have two different sets containing the same elements, we say that they are the same or equal. And then an example of concrete set is something like a hash set. So let's take a look at a hash set example. Here, instead of declaring an array list, we're declaring a hash set of type what? Ping? What is the type of the hash set? Yes, string. And then in the next line, we have an array, right? An array of string. What are the, boom. What are the, what are the elements in that string array? Fourth line, fifth line. Okay. Now, my question to you is, are there duplicates in that list or in that array? Okay. So, good. Wait, you said no?
He said yes.
He said yes, right? Okay, thank you. Sorry. So there are duplicates in that array of string, okay? And what are we trying to do? So I'm testing your code reading skills. Ploy. My next question is, in the for loop, what are we doing to the set? Okay, that's one. We are printing. That's a good start. But that's not the point that I'm trying to get from you guys. What are we really doing in that class? We certainly are printing, but based on what condition? Perfect. So did you guys hear what she said? She said that essentially we're trying to add to the set each of the string element. Okay, if it got added, then we want to print that it got added. If otherwise, then we print that it did not get added. Yes, Andy.
Would set.add return a Boolean?
Perfect, because right, I mean that's the whole point. Why what it returns? I mean, it's supposed to be able to tell us.
Is that a void method?
No, it's not a void method, because like if it was a void method, then you wouldn't be able to use the if statement. Now my question is like, when is the case when it'll actually be true? When you add. Go back to the definition of set. Pao Pong. So can you tell me when it will be true and when it will be false when we add something? And who can help too? hold on, sorry. Let me just gossip openly about your classmate. You know, on the exam, this one guy, a lot of the pages, he had put his signature, hoo. I was like, what the heck? And actually, one guy, I don't remember his name anymore. Perhaps the midterm was not tough enough for him. He had the time to put still images, like to put cartoons, drawing on the top right of the images, and he had the guts to tell me that, Ajahn Khap, please go through each slide and then like flip through it quickly because you see an animation. Animation in obviously the midterm was not long enough. So you guys know what's going to happen, right? What's going to happen is that we are going to increase the length. This means that we're getting feedback from your classmate that the midterm is not hard enough. If you have the time to actually put animation in each of your page, I think that we shall, and we should, we ought to increase the length of the final exam. And then, you know, there were funny references like one guy, okay? You guys all remember the 40-point problem, right? Yeah. One guy, he left the page completely blank with the exception of the top right. He said, GG. Game over. Anyway, okay, enough digression. So Papong, what did you say? What did you say about the add method? Under what condition would it return true, and what condition will it return false? Repeat. Ah, right. So it will only return true if it's not a duplicate, right? Otherwise, if the item, the new item you're trying to add, is actually a duplicate of the, if the item you're trying to add already exists in the set collection, then it will return false. So what do you think what do you think the output will be when you actually try to run this program? Josette, what do you think the output to the screen will be when you run this program? See you at our office hour. Huh? What? Okay, keep going. I guess at this point we might as well just have you keep going. And?
C is added.
Yes?
A is not added.
Okay.
D is added.
Okay. And
Has for element.
okay.
D, A, B, C.
You just took an official eye exam. So it seems like your eyeglasses still function. No, but Josette, the question is, Why is it that A is not added in the fourth line? What's so special about that A that causes the program to not add A? Duplicate, right? Because in the original list, if you see there's A, B, C, A, D. A is the only character that is a duplicate, right? That contains a duplicate element. And that's why when you're talking about a set, since a set does not allow you to have duplicates, this is why we're printing out A is not added, because when you try to add to the set, it returns false. Is that clear, Joseph? Okay, loud and clear. All right, moving on. So set implementation. So we have different, whoa. Oh. Oh, it's unordered. Hash set is unordered.
No, it's like now.
You can think of it that way, I think. I mean, there's no guaranteed. This is why, on the next slide, hash set contains unpredictable order. I read your mind. All right. On the other hand, if you wanted the insertion order to be maintained, you can use something. You can use the class linked hash set, because this one maintains insertion order. So, since you guys, during the office hour, you guys all ask me what kind of questions are going to be on the exam, I might as well jump the gun and tell you right now that you should expect us to ask you or give you a program and then ask you to write out the output of the program based on different collection type. So for example, you can expect to see something like this, right? Hash set, and then we might ask you to write out the output from the JVM versus linked hash set, okay? What are we trying to test you? We're trying to test you that you understand the difference between hash set and linked hash set. Linked hash set maintains the order, the insertion order, while the hash set does not. And lastly, we have the tree set. Tree set is a balanced binary tree which is sorted and less efficient. It's less efficient precisely because it's sorted, okay? But you guys don't have to know that much. All right, list. We've already looked at lists before, but we're going to look at it again. A list instance is a sequence. A sequence of what? Sequence of elements, okay? The list interface contains methods inherited from collection plus positional access, search, and range view. Whenever you think of list or whenever you see the list, I want you to have in your mind that it behaves very similar to the native array class. Except that it's sort of like the array class, the regular, I'm sorry, I don't mean the array class, but I meant the native array. You know, the bracket native array? You know what I'm talking about. I want you to think of the list classes as the native array on steroid. By that I mean it contains more methods that you can use to access the elements. So let's take a look at what you have, what methods you have. So we're looking at the interface for list, right? Okay. You have positional access. What do we mean by positional access? You guys already know this or familiar with this syntax. By that we mean if we had int a right, that is the native array. And what I'm trying to tell you, what the positional access is something like that. When you have the array and then you access it based on the array index. So you have a 5-element array and you are accessing it via the integer index. That is what we call by positional, that's what we mean by positional access, accessing it based on position. So it's no surprise then that when you see get, set, you have to specify the index. And you know that all index are 0-based, right? And then you can add, right? You can actually even add and specify the index that you want to insert it at. You can remove and you can add all elements from some other collection given the index, starting index within your collection. The point is not to memorize these methods. The point is to understand the capability provided by the list classes, okay? And you can only internalize these methods only after you've used these classes for a while. Additionally, you can also access or search for the objects you are looking for by passing the object that you are interested in and then have it return the index, okay, the corresponding index within the collection as well. And then iterator, right? You can get the list iterator from the list collection. And those are the methods that you would use to obtain the iterator. And you can also tell it, oh, you know what? I don't want the iterator to start from the beginning of the list. I want it to start from some position, some index in the list, right? And that is when you would use the second list iterator method. You can also even get a range, right? This is what we mean by a range view. You can tell it, all right, sublist, I only want, for example, if you have a 4-element array list and you're specifying that, you know, I want to get in from 1 to 2, then you would be returned the list containing only 2 elements as the return parameter. Is that clear? Again, just be aware that these methods or capabilities exist, but you do not have to memorize. Okay, I don't remember any of this. In fact, I just remember them now that I'm looking at them. So we talked about the iterator interface prior to this. Now let's take a look at the list iterator, which is specific to just the list array or the list classes that we've been looking at. The one difference between this list iterator and the previous iterator is that the list iterator does not point to an element. Rather, it points to something in between. Okay? This is why, well, let's talk about the functionality or the reason why it exists, first of all. List iterator, just like the iterator class previously, allows you to traverse in either direction. And that's really important because if you remember the iterator class, right, only has what? Has next and the next methods, right? It only allows you to get the next element. Whereas the list iterator allows for random access or bidirectional access. You can get the previous one or you can get the next one. and you can traverse in both directions. Okay, and we'll see the methods in the next slides. But here you already see two methods. You see the next method, and then you see the previous method. Okay. So what is a list iterator defined formally then? A list iterator has no current element, as the slide or the image shows you. Its cursor position always lies between the element that would be returned by a call to previous and the element returned by a call to next. Okay? So let's take a look at a concrete example. Well, let's take a look at the methods available before we look at the example. You can probably tell, right, that it's going to be quite similar to what you had seen earlier, except that what you had seen earlier from the iterator class, with the exception that now you actually have the has next and the previous, which is really important because prior to this, the iterator class only contains the next methods. So you have the has previous, and then you have next index, previous index. This is index of the collection. Then you have your remove and set and add. So prior to this, we did not see add, right? We only saw remove. Now we have set and add as well. The difference between set and add is that set would set the element E to the current position that your iterator is pointing to. Essentially, it's modifying or replacing, while the add actually inserts something. Okay. Anyway. Linked list example. So it's quite a long slide, but let's go through the important one. So let's go through the example. So I don't know, I don't play cards that well, but you can have like the number of hands, number of cards, the normal 52 deck card, right? And then you essentially constructing the 52 card deck using the for loop, right? You know that a suit, we have 4 suits, and then we have those ranks, right, from ace to king. So essentially, we simply just adding cards, creating cards, adding to the deck. So now we have a 52 card deck, okay? And now here's an example of the algorithm provided by the Java framework. When you guys play cards, what is the first thing that you have to do before you play it? Money, yeah, and shuffle, right? And this is why, and because the Java framework author knows that you guys are all a bunch of gamblers, they have to provide shuffle method, right? And this shuffle method does not restrict itself to just cards, okay? Don't mistake this for shuffling cards. You can shuffle, by definition, shuffle or shuffling shuffles the elements within your collection, okay? So the point is, shuffle is an example of algorithm provided by the Java framework. All right, next, then you want to just print out what you have, right? Now that you've shuffled the deck, you want to just print out what you have. And the deal hand list, you just want to print out what's in your hand. You get the sub list, right? And you get the hand stuff. I don't know, I didn't study this code, so essentially we're trying to show you an example how you could use the array list and the linked list. Okay, it's a nice example, I think. All right. So for example, right? You guys know that I mean, this is a simulation of a game, right? Like you have the 52 cards, you have 4 people, right? 4 hands, that's why you call 4 hands, and then each one has 5 cards. And this is the output, for example, if you pass in 4 and 5 to this example. So I think the key takeaway from this is that choosing the right data structure, the right collection class, has profound impact on how easy your program is going to be. Because, like, for example, you see how, like, when we got the hand view from this, we used the sublist method. Imagine that you implemented the deck, okay, the deck variable using a regular array. The impact of that is that you would have to yourself implement the sublist method, right? But if you knew that, oh, okay, well, when I'm given this kind of problem, I can just use the list collection, then you would get the sublist for free. This is what we mean by knowing how to use the right collection class for the right context. Okay? For example, if you wanted to implement the to-do list again, okay, but if you wanted to be able to search through the list, the to-do list, somehow, you might not want to use the list class. Instead, you might want to use, I don't know, like the map class, right? Because the map allows you to search, we haven't covered this, but the map class allows you to search for elements based on the key, okay? So I thought of mentioning that to you, that the point of, knowing how to pick the right class, collection class is very important. It has profound impact on how readable and how maintainable and how functional your program is going to be. All right, so now we're looking at the concrete implementations for the list. You have array list and linked list. I'm going to explain to you why is it that we have comments such as largely unused space, penalty when size exceeds capacity, more efficient on methods using indices for array list, and why is it that we say that linked list wastes no space. And I'm going to be very quick on this. Man, this eraser is not that effective. Oh, it's much better. Because of this, because when you think of array list and when you think of linked list, I want you guys to have this image in your mind. Suppose that we are modeling a 3-element to-do list. Okay, this is a to-do list. And this is like task 1, task 2, task 3. I want you guys to have this image when you think of the array list and linked list. Do you guys remember the difference in terms of implementation for list versus array? Maybe not, that's fine. You see, normally when you talk about array, the main difference, okay, between an array and a list is that for array, all elements are contiguous. They are right next to each other on the computer memory. Whereas when you're talking about a list, each of the item does not have to be adjacent to one another. And most of the time, I think I'd say almost all the time, they're never adjacent to one another. But when you have a linked list, the way that you traverse through each of the element, right? You have what we call a pointer, or basically something that tells you where the location of where the next element is. Whereas when you're talking about an array, all elements are contiguous. So when you're here and you want to move on to the next element, you just have to move to the next memory cell or the next memory location to grab the next element. Now, let me address each point individually. First, we start off with the array list. Why is it that the slide says that the array list has largely unused space? The reason is because when you allocate an array list, especially when you have like large number of collections, most of the time you actually have some allocated space that is not used for anything else, because like it's very expensive, okay, when you allocate an array and then you keep inserting. Hold on, let me take that back. Let me say this again. When you allocate an array of, I don't know, size n, like let's say 1,000, it doesn't allocate 10,000 element long array. What the array actually does internally is that it allocates some space to accommodate the scenario when you actually add more elements to the array. Precisely because it's very expensive when size exceeds capacity. Why is it expensive? Because the restriction of needing to have all the elements be contiguous means that if you keep adding to the point where you exceed the pre-allocated memory space, what happens is that JVM has to allocate new contiguous space and then copies all of the elements over to the new space. This is what we mean by penalty. By penalty, we mean that you have to copy all the elements from one memory space to another when you exceed the capacity. Is that clear? So, as an example, if you had an array that allocated 10 elements for the space, right? And you added the 11th element. What happens internally is that it will allocate it like new space, maybe 20 long, not exactly 11. And then it copies all the 10 elements, and then it inserts the 11th element, leaving 9 element long space for you. Do you guys see that this is why we say that penalty, you have penalty when the size exceeds your capacity, precisely because of the array element contiguousness restriction. Yeah? Whereas linked list does not have that restriction. As I had indicated earlier, when you're talking about a linked list, each element is simply linked together. So that means that if you allocated a linked list of size 10, okay, and you added the 11th element, it will simply just add on the new element without needing to worry anything about ensuring that they're all contiguous, because linked list by default is not contiguous. This is why we say that when you're using a linked list, it wastes no space. So if that's the case, then most of the time you would use linked list then, right? Why would you want to subject yourself to the possibility of incurring penalty? Well, let me tell you, because I had a lot of experience programming, I had a lot of experience creating high performance applications, specifically scientific applications. You see, the way that scientists model a lot of signals in the world is to use a 1D array, for example, like sound. I think you can model as a 1D array. And a lot of times, what these scientists have to do is to loop through each of the elements and perform some math operations on it, whether it's like Fourier transform or whatever, right? It's very important that all the elements must be contiguous, because if they weren't contiguous, it takes a lot of time for the computer. So this is related to computer architecture now. It takes more time for the computer. If you look at this diagram, it takes more time for the computer to grab each of the element that is not contiguous than to grab each element whose position is contiguous. Okay, is that clear? This is why, so for the case when you want to have efficient access based on indices, you want to use the array list. Okay, so if performance, traversal performance is your goal, you want to use the array list because all elements are contiguous in memory. Whereas if you want to just have waste no space, right, and you just want to like traverse through the loop and it's not like critical that it must be fast, then you want to settle for just using the linked list. Is that clear?
Yeah.
So if you ask me like what should you use normally, if it's just a regular GUI application like the ones that you'd be developing, you would want to use something like a linked list. Whereas if you had to, for example, in your project, like an image, right? An image is stored as 2D array, for example, or 1D array. For those cases when you actually have to manipulate large collection, you would want to use array list, for example. Okay. So I'm just giving you guys explanation behind all these points. So what was the one algorithm that we had seen in our previous example? Shuffle, right? Is that the only one that is provided by the framework? Craps. No, right? I mean, you have a bunch of them still. And we have like 7 minutes left. So I'm going to go a bit more quickly. So queue, right? I'm glad that none of you is Chinese because like otherwise I would have to explain what queuing is. But since you guys are all people that understand the concept of queuing, we can skip quickly, and that queue is just that, FIFO, right? First in, first out. When you have something queued, when you try to extract something from that queue, you would get the first element that was inserted into the collection. And those are the methods that are provided by the queue class. And we want to just highlight, okay, the difference between add and offer, remove and pull, element and peek. The only difference between the left column and the right column is that the left column will throw an exception when something is exceptional, while the right column will never throw exceptions and will only return you some special value, such as false, null, null. So when would we have exception on the left column? Well, you would have exception when, for example, you try to insert something into the queue and you ran out of space, for example. Or you try to remove something from the queue, but the queue is actually empty. Then you would get a no such element exception. On the other hand, if you are scared of exceptions, you can simply use the corresponding methods on the right-hand column. Okay? And in those cases, I hope that you would put in some if statement to check what the return values are. So the point is, what's the point? The point here is that the queue collection class provides you with methods that throw exceptions and methods that do not throw any exceptions. And which one to use depends on your context. So here's a queue example. You simply just queuing up a bunch of string, right? A, B, C, D. And we simply just traversing through each one. And this is what you're going to see. And then since we are trying to maybe like removing one more, we're trying to remove one more than what we have in the queue. That's why it throws an exception. Pretty simple. So the second example, on the other hand, uses the exception thrower method. I don't know if that's right, but we're trying to use the poll method as opposed to the remove method, right? So in this case, since we're trying to remove one more than what we actually have, it simply returns null. Map. Map is dictionary, simply. Remember, when you think of map, I want you to think of this image. So you guys should remember that well. Because a map simply is an instance of keys. So by keys, just remember that it's the word you're trying to look up in your dictionary, and the values is the definition of that term, of that word you're looking up. A map cannot contain duplicated keys. Makes sense, right? Think about it. If you had a dictionary and it had like the same terms listed right next to each other, it wouldn't make sense, right? On the other hand, if the dictionary were to be written by Vicky, it might make sense that you have duplicates, right? Because she actually enjoys having duplicates in her list. So I would think that she would enjoy having it in her dictionary as well. Would you have duplicate in your dictionary? No? Not anymore? All right. Each key can map to at most one value. Okay, so it's a one-to-one mapping, right? For example, you have, the word gist, G-I-S-T, and that is G-I-S-T. The corresponding translation or definition would be point, the point of something, right? The crux of something. It would not be anything else, since we're talking about normal dictionary. On the other hand, if you had a map of Urban Dictionary and you looked up something that sounds kind of like gist, you might get something else. And that's okay. That's going to be your homework, right? Or you can ask Niran what he's an active contributor to Urban Dictionary. All right. A map model is a mathematical function abstraction, blah, blah. No. Sorry. These are the methods, okay? And let's take a look at an example. So these are the concrete implementations. And I think we've already gone over this once already. So we're just going to keep going. So an example, all right? A hash map, tree map, linked hash map, whose key is a string and whose value is an integer. So this is how you would use it, right? Regardless of whether you see, this is the beauty, okay? The beauty of interface. Irrespective of what concrete map class you chose, you use the method the exact same way, right? I mean, imagine if you had to memorize for the exam the different methods to achieve the same thing, right? You're trying to just put something into the dictionary and you have like, maybe one method would be called like put, and then the other one would be like put one, and then the last one would be like really put, that can really cause a brain fry, right? This is the beauty of interface. You see, the beauty is that you can, irrespective of what the implementation is, you share the same interface. You share the same method signature. And I hope that part is clear, that regardless of how you implement it, you use it in the exact same way. Okay? And you keep putting and then you print out, right? You show the pairs. And how do you show the pairs? You simply just, you can iterate, right? So the map contains or has the iterator method, and then you can loop through. And then how do you get the key and the value? Well, when you iterate through it, the next would return you the key, and then you can use the key to get the value. So here, it.next returns you the key, and then m.get, passing in the key, would return you the value.
I don't really get key and value.
So when you think of key and value, I want you to always remember dictionary. When we're talking about the dictionary, right, you have the term and then you have the definition, right? Key is something that you use to look up. Key can be anything, can be numbers, string, anything. Whereas the value is the corresponding, the associated value that comes with the key. How should I explain it? Hey, who help him running out of time. Explain to him the key and value. But I mean, precisely, right? Key is simply what you use to look up in your map, and the value is the corresponding value, the associated value that comes with the key. All right, map example, last thing is, I don't know what's here, but you know, here you just have another example of the map. And example, counting colors. This is a practical application of the, sadly we will not have time to go over this. So it's a JFrame application. Whoa. Hey, what happened? I am going to buy the new VGA connector today. You better believe it. I've been saying that for the past 2 months, but today is the day. Crap. Hold on, we still need to, okay, so you see, so this application will essentially load an image, right? And then it will count the color. So you see, you can think of, okay, damn it, don't remember your name. What's your name again? Nat? Nat? Oh yeah, Nat. So this is an example. In this example, we have color, okay? The RGB color value and then the count of how many times you see that color in that image, I think. This is a visual example of the key value. Sorry, I have to cut this short, but we should go over the homework. Chan Jiwong. Yes. Whoa, look at it. Got updated. Hey Putti, I told you not to start doing the homework. Just kidding. I'm just kidding. No, it's not him. It's the fake students. All right, Scribble applet, right? What do you think we're going to ask you to do since you just learned about framework or collection framework? Undo, right? That's what we want you to do. So how do you implement undo? Really quickly, right? I mean, the way that you should have implemented your Scribble applet was that you should have saved for each stroke the value of what you did, right? In a collection. And to undo, simply just remove the last collection, the last element, right? The last action, and then just repaint. And then that would be the undo, how you would implement the undo. Right? So in this case, you can use the collection like some data structure to implement the undo. So I hope you guys have been saving each of the action in some data structure. And Ajahn Jiwong would like to also add that, for this homework, for those of you who did it properly, if you just sit down and think a bit, you can quickly finish this homework in a few lines. Yeah, because it's just undo. You're adding the undo to the menu item, and then when you click on that, you simply just remove the last stroke, and then it will undo, and then you repaint everything. right? So that's your homework. And you know that we are going to be assigning group project really soon. And that is all for today. But before you guys go, Jia is not here. I need to take attendance. So what's the date today? March 8th. Chayut? Huh? Chayut is not here? Oh. Okay, I think I'm gonna skip these guys. กุลประภาปี3เหมือนกันกุลประภาวิกกี้จอมพจน์จำได้